Okay, we're going to look at how to use our mole island map to do some stoichiometry problems. Here we have a balanced equation, and we're going to need one of those to do this. Now in our problem, it says if you have produced 63.42 grams of H3PO4, right here, how many molecules of HClO4 would you have needed to start with? So I'm going to underline what's given to me in my equation, or my question. And I'm going to circle what they're looking for. So we're given grams of something. I'm going to call that A. So we're given grams. Oh, it slid off the screen. Grams of A, grams of something. And our question, we need to get to molecules of something else. So we need to find molecules, so atoms or molecules of something else. We have to get from this island to this island. And there's going to be one bridge, two bridge, three bridges, which means we know it's going to be a three-step problem. So let's start with what we're given. 63.42 grams of H3PO4. I know I don't want grams of H3PO4, so I'm going to cancel that unit down here. Remember, the of is not necessarily needed. We just put it in there for convenience sometimes. Now, when I'm in gram island, to get to mole island, I know I have to use the molar mass of the thing equals 1 mole of that thing. So I can go from grams of this to moles of this. Remember, I can never change more than one of these units. So if I change grams to moles, the of what must stay the same. And this is the molar mass, the grams per mole. So grams per mole, which means per 1 mole. I need to find the molar mass of H3PO4 from my periodic table. So using this, I need to look up the mass of 3 hydrogens, 1 phosphorus, and 4 oxygens. So we'll take, 1.01 times 3 plus 30.97 for phosphorus plus 16 times 4 for oxygen to get me a grand total of exactly 98. So the molar mass of H3PO4 is exactly 98 grams. Cool. So that gets me to, I'm now on mole A island. But this will cancel. Oh, grams cancels too. But I don't want to be in moles of H3PO4. I want molecules of HClO4. So we have to keep going and then cancel moles of H3PO4. Now, if I'm here, I can go from moles of A to moles of B using my mole ratio and the coefficients in my balanced equation. So I can go from moles of one thing to moles of the other thing. That's my mole ratio. So moles of this to moles of the new thing I want, which is HClO4. Now mole to mole ratio, so in my balanced equation, H3PO4 has a 4 in front of it, and HClO4's got a 12, which means I need 12 moles of this to make 4 moles of this, which means this will now cancel with this. I'm now on mole B island, and I've got moles of HClO4. But I'm not done, because I need to get to atom/molecule island to get my molecules of HClO4. So I keep going, which means this unit has to cancel. I always take this one down here until my top unit is the one I want. So moles of HClO4. And to get from moles to grams, moles to molecules, I have to go from moles to molecules of HClO4. So 4. And I know that 1 mole equals 6.02 times 10 to the 23rd molecules of anything. That's Avogadro's number. So it means this will cancel with that. I'm now in molecules of HClO4. That's why I circled, which is exactly what I've got here. So hey, all my steps are done. I just need to do the math and hit equals. So I'll take 63.42 divided by 98 times 12 divided by 4, that's what this line means, right? Divided by 4 times 6.02 times 10 to the 23rd, get my answer. Ignore these ones because multiplying or dividing by 1 is the exact same thing. Hold on, 63.42 divided by 98 times 12 divided by 4 times 6.02 times 10 to the 23rd gets me 1.17 with a little rounding times 10 to the 24th molecules of HClO4. And that's how you use the mole map. Hope it helps.